Welcome to the last video we'll watch on just how do we simplify a complicated limit sort of problem. We're still looking at this indeterminate form. When we plug in the x value that we're interested in, we get 0 over 0. That usually means we can somehow simplify it. And our third example is basically just simplifying, trying some algebraic method just to get it in a different form. So no super easy trick for this one. We just have to kind of tough it out and try stuff. So here is the function that we're going to look at. It does look a little complicated. Again, if we were to plug a 0 into this, obviously the denominator is going to be 0. But if I plug a 0 into the x in the numerator, that first chunk I just get 1/4, and I'm subtracting 1/4. So hopefully you can see how that turns into 0 over 0. Also, if we were to graph this, we would get something that just basically looks like this. Let's just say I went to 1 on this side and -1 over here and 1 up there and -1 right there. It's a pretty simple graph. It just slowly climbs a little bit here and just kind of levels out. It does look like there's some sort of a limit idea at 0, but obviously we're not going to be getting necessarily an answer there because there's going to be a hole of some sort. Because we can't plug in the 0 to the original function. So let's just try to mess around with this, try to figure out how we might make this thing work. So one of the first things we'll do is just maybe rewrite this so it's in a little bit of a nicer form. Again, just kind of paying special attention to the fact that we should be writing this limit idea in front. Okay, I just feel like the fractions look a little messy. So just want to remind you that the first one really just means this, 1 over x plus 4. Now we're subtracting 1/4. And then I'm just going to suggest that maybe we do this. We put big parentheses around this. Instead of dividing this whole thing by x, let's just think of multiplying this by 1 over x. And we're just going to kind of ignore that 1 over x for a little bit and just focus on the stuff that's in the parentheses. And before I get too far, I also just want to mention that this original question here, next year in calculus, this specific idea is going to mean something to you within about a month of being in class. So there's also a special reason that we're starting to look at something complicated like this. You're going to see more of this next year in calculus. For a little bit. I don't want to scare you off by any means, but this has a deeper mathematical meaning, and then we learn some shortcuts that makes this whole process much easier. Okay, so we have two fractions within those parentheses. Let's try and come up with, let's try to combine them. We need common denominators for that. So again, we have the limit as x approaches 0. We have this first fraction of 1 over x plus 4. And we're going to subtract the fraction of 1 over 4. Okay, and I left a little space there because I need to come up with these common denominators. So I would want to put a 4 in this first fraction, which means I also need to put a 4 in the numerator. And then just a reminder that we probably now want to put parentheses around that original denominator. Okay, and then for the second fraction, I would need to include an x plus 4 in the denominator, which means I need to include that in the numerator as well. Okay, we close all of that. That was the original stuff that was inside the parentheses, and at the end I still have that 1 over x. Okay, good so far. Hopefully now we're going to combine the two fractions that we have there. Again, trying sloppily to write the limit as x approaches 0. Okay, now we're just going to have one big fraction. So it doesn't necessarily matter the order we put this denominator in. I'll put it in with 4 times x plus 4. I'm not going to try to simplify that right now. Let's just leave it the way it is. The first part of my numerator, so hopefully you can see a highlighter here, but right here, that's just 1 times 4. That's going to get me the number 4. Okay, and then in the second part, it's a little bit more complicated. Remember that these things are going to be subtracted. So I have 1 times an x, so I'm going to have a minus x. Oops. Okay, and then I have a 1 times a 4, but I'm subtracting that as well, so that's going to be a minus 4. Okay, all of this is in parentheses, and I still have this 1 over x at the very end. Okay, now the only major change that I can make here is in the numerator of the larger piece, I have a 4 and I have a minus 4, so they're going to cancel out. So this whole idea will simplify to the limit as x approaches 0 of, now instead of 4 minus x minus 4, we just have a negative x, okay, over 4 times x plus 4. And then that's going to be multiplied by another fraction. I'm just going to kind of drop the large parentheses we've been using for a while. They don't necessarily matter in this case. But I still have this 1 over x that would appear at the end. And so if I have a fraction times a fraction, and we have several chunks here, but what I notice is I have a chunk in the numerator here that's going to cancel off with the chunk right there in the denominator. That negative symbol is still important, so don't forget that. But now if I rewrite the simplified version, I have the limit as x approaches 0 of, and the numerator is negative 1, and in the denominator I have 4 times x plus 4. And now there's absolutely no issue with plugging that 0 in. So for my next part, I don't need to write the limit anymore because now I can actually plug in the 0. So 0 plus 4. And if I simplify that, I get negative 1/16. So if you go back to that picture that I showed you on the previous slide, I said it kind of, my box was from negative 1 to 1 for both x and y values, and it does get very, very close to the x-axis as we get close to x equals 0. It's almost at 0, in fact. So, yeah, again, jot down some questions, and we'll see you in class.